Thank you. Ah, pointing. Okay. Have to try this first. Yep, it works. So, good afternoon. My name is Jutta, and I come from the LUT University. So, as we heard from the previous speaker, we will be creating a consortia with Lahti Polytechnic. So, after that, we are Lappeenranta-Lahti University of Technology. Right, but I'm here to tell you about this Urban Infra Revolution project, which is one of the projects that LUT Resource Research Platform is running. And it all started with this. So we are located here in the southeast Finland, and there are plenty of big players in the region which are producing side streams, or used to be called waste, but that's a no word nowadays. So something that they have no value to, and something that they have to get rid of. Then we have a technology provider in the town, Outotec, and Outotec with us. We came with the idea that we should do something together to get rid of these side streams and also add value to them. And what was very important was also the new approach which came through this company. It's an SME in Imatra, and they do 3D print, so it's additive manufacturing, but usually people know it as 3D printing. And we are not talking about the desktop 3D printers. We are talking about big ones. So something that is able to print walls, for example, of a house. So big scale 3D printing. So we connected with Lappeenranta City, and they got enthusiastic about this idea because Lappeenranta has its own sustainability program called Green Reality, and their aim is to create a very low carbon infrastructure to the town. And this all ended up when we then looked for some funding for this idea, for realizing it. We got some funding from this urban, oh, now it works when it's not supposed to. Urban Innovative Action. It's an EU initiative which funds cities, so city ideas. The applicant must be a city. And we got a quite nice sum of money, and it ended up with this. So we do have these partners here with their site flows. We have the technology provider, we have the 3D printer, and we have loads of material, and we are producing geopolymer concrete. This material is something that has a significantly lower carbon footprint than normal concrete, and it has some specific characteristics such as that it doesn't leach. So even if there is something harmful or not, or the concentrations of some substances are high, this material, as its nature, is such that it doesn't leach to the environment. So that was one very good thing. But this material, this geopolymer concrete that we are producing out of these things, it should be also 3D printable. So that was the basic idea. And then when we are 3D printing, we are not restricted to any form anymore. If you think about concrete buildings, for example, or any structure, they are usually cubical and such. But when you 3D print, and your material is such that you are not reliant on the steel enforcement anymore, you can create forms, whatever you wish. And this was one of the things why the town was so keen on this, so to get the silhouette of the town to look better. Geopolymer concrete, it's something, it depends on the aluminium and silica content in the side flow. So we have to find the right side flows to combine, because it's not geopolymer if we are not doing the bonding between these two ingredients here. And this shows the consortia. So we have plenty of players. We have SMEs and we have large companies. We have polytechnics, we have our university, and then we have designers, and of course the town, the city. And this creates quite a unique combination of players doing things together. It all started with loads of characterization. So we collected regionally and also then from Finland samples of different kind of sine flows and characterized them. So we were mainly, of course, interested in the silicon and aluminium content, but also on the shape and the size, because these are also relevant factors for creating this geopolymer. And also the dissolution tests were done. So plenty of chemistry behind here. Then we started with a recipe development. And this is done by a SME, an Apila group company. And this is actually one of the first things that we have been able to print out of the developed geopolymer. And one of the very unique characteristics of this material is that it hardens very quickly. So, for example, in Australia, they do use geopolymers in replacing the concrete in the airport. So on the runway, if there is a hole, they don't do the patching with normal concrete because it takes ages to dry, but they take geopolymer. So it's something that is very unique and also usable in many applications. We are doing the method development. So this is the printer. So we are talking about a big thing. And the idea here is that eventually, when we start printing, the printer will be taken on the site. And it prints there. Okay, I'm running out of time. Right, but this is so interesting, but let's cut it short. Okay, we do the sustainability assessment, and you can see that the geopolymer compounds are much less carbon intensive. We think about the product safety, we do testing and so on and so on. We had an idea competition in Lappeenranta, so the citizens could say what they want to be done out of this material. And the skate ramp was actually, the skate park was the winner. And then we are doing and using also virtual reality to show what this is going to be looking like at some point. And then we are doing the business studies. So this is circular economy, a great example of it. And when we are building up this business ecosystem, there are places for actors that didn't exist before. So we are doing studies over that. So in this kind of a research project, we are creating, or actually maybe not creating, but pointing out possibilities for SMEs to take responsibility of some part of this value chain here. And of course we are also thinking about the revenue generation models and actual business models of the actors and so forth. So, to cut a very long story short, I'm grateful for the funding from the UEA and also from our great project team. And if you have any questions, I'm happy to answer.
Thank you, Jutta. Any questions for her? Yes, there.
Okay, so my question is that, so I have ever started working in the geopolymer field since 2011, so I have some background in this. So what I'm curious is that for the 3D printing, you said you have been using side streams, but what exact side streams have you been using?
We have been trying many of these side streams. At the moment, we are having fly ash.
Fly ash
from, for example, UPM, so bio-based food, bio-based. But also we have tried the coal ash. But the thing is that in the future we won't have any coal ash. So we better base it on something that we can rely on, that we will have. And one thing I just forgot to mention is that this is a local, sort of a local solution, but it can be multiplied anywhere where you have this kind of a area where are different players with different kind of side streams. So, but yes, we have done quite much of the testing, and have to say that not all of these side streams do have enough silicon or aluminium, and that's the restrict. Yeah. Welcome.